Hi guys, so we're looking at question 1 on homework 13. So question 1 basically is a bunch of law of large numbers Chebyshev inequality questions. It's just in each and every question you have to calculate a different parameter. So in one case you have to calculate n, another case you have to calculate epsilon, another case you have to calculate sometimes expectation of x plus epsilon. Sometimes you have to calculate the parameter of your distribution like p. So it's just basically drill questions on Chebyshev's inequality and law of large numbers, just so that you guys get your concepts straight. Now let's look at part 1 of question 1. So what is part 1 asking? So you have a die and you're rolling it 100 times, right? And each xi is the outcome of the die roll. So you have 100 xi's, and each of them can be 1, 2, 3, 4, 5, or 6 with probability 1/6. What you want to do is, after 100 throws, you want to find an interval a comma b such that your expectation of a will lie within that interval with a very high probability, that is 90%. So we want to find some sort of bound on a and b, or how far away they need to be from each other and where they need to be, so that you're very confident that when you roll a die 100 times, the average is going to come out to be in that interval. So this looks like a law of large numbers question. Well, it is a law of large numbers question. And how do we go about doing this? First of all, let's decide exactly how we want to describe our interval. So we want a comma b, but in order to use the tools which we are very used to, like Chebyshev's inequality, we would need to describe this interval in a very particular form. How do we shape or phrase this interval such that we can actually easily solve this question? Well, let's actually phrase this interval as in terms of the deviation from the mean. So let a be less than equal to expectation of x, because we know that as we throw the die several times, maybe 100 times, it's going to go, the average is going to go closer and closer to the expected value of one die roll, right? So let's phrase it in such a way that our interval can be described in terms of the mean. So so let's actually put a is equal to expectation of x. You know that the die rolls are going to tend towards the expectation, so we can just bound the interval around surrounding the expectation, minus some epsilon, and beta b is equal to expectation of x plus some epsilon. Therefore, now we want to make sure the probability that a belongs to expectation of x minus epsilon, comma, expectation of x plus epsilon is greater than equal to 0.9. So now we see that this is just Chebyshev's inequality, right? We're trying to bound the probability, or rather, so if you want a to lie within this interval, therefore probability that a does not lie within, I'm just going to say a comma b, is equal to 1 minus probability that a does lie in a comma b, which is less than equal to 0.1, because 1 minus 0.9 is 0.1. So now we see this thing, right? So we see probability of a not lying in a comma b. What does that mean in terms of what we've described a and b? It means that this is basically the probability that a is further away from the mean by more than epsilon, right? So epsilon is exactly in between a comma b. I'm just going to take that off. Is exactly in between a and b. And if a doesn't lie, expectation of x is exactly in between a and b. And if a doesn't lie in between a and b, that means it lies more than epsilon away from the expectation of x. And this is, let's just say expectation of a. That's what I meant. But expectation of a is equal to expectation of x, I think, from linearity of expectation. So it doesn't really matter, but I should just write that. All right, I'm just going to change that everywhere. Yeah, but expectation of a is equal to 1/n sigma expectation of xi, which is just n over n expectation of xi. So it's the same thing, so it doesn't matter. So what do? Now over here, when we're trying to bound how far away a is from the expectation, we can use Chebyshev's inequality. So this inequality exactly is equal to, let me just write that out, a not belonging to a comma b is equal to probability of a minus expectation of a is greater than equal to epsilon. And this, using Chebyshev's inequality, can be bounded by variance of a over epsilon squared. And this is less than equal to 0.1. Right? So now all we need to do is find epsilon. And once we find epsilon, and of course expectation of a, then we can find our interval. So in order to find epsilon, we need to know variance of a. So let's find variance of a first. Expectation of a is just going to be this, which is equal to expectation of xi is just going to be 7 over 2, which is the expectation of a die row. Now let's calculate variance of a. Variance of a, as you know, is going to be variance of 1 over n sigma xi, right, which is equal to 1 over n squared. Variance of sigma xi, which is equal to 1 over n squared times n times variance of xi, right? Because since the xi's are independent random variables, the variance of the sum is equal to the sum of the variance, and since all the variances are the same, it's just n times the variance of 1, which is equal to 1 over n times, what is this? Expectation of xi squared minus expectation of xi the whole squared, which is equal to 1 over n times, what is expectation of xi squared? Each and every point has probability of 1 over 6. It's 1 plus 4 plus 9 plus 16 plus 25 plus 36. So for each and every xi, you take the square, and if xi has probability of 1 over 6 of occurring, then for the random variable xi squared has the probability of 1 over 6 occurring, right? Plus 1 over 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6 the whole squared, right, which is equal to this, this is minus, which is equal to 1 over n times, I think that comes out to be 91, actually, one second, that comes out to be, well, this entire thing comes out to be 35 over 12. I've already calculated that, and it's just basic algebra, so I really don't want to do that again. So which is equal to 35 over 12 times 1 over n, and we know n is equal to 100, so it's 1 over 100 times 35 over 12, 5 goes in at 7 times 20 times, just equal to 7 over 240, right? So we have variance of a is equal to 7 over 240, and expectation of a is equal to 7 over 12. Alright, so now we have that information. All we need to do is find epsilon squared. So we have epsilon squared is greater than equal to variance of a divided by 0.1, right? Which means that this is equal to 7 over 24, right? So we have epsilon is equal to, is greater than equal to square root of 7 over 24, which is approximately equal to 0.54, right? So now we have our interval. We have expectation of a, we have epsilon. So now we just want the interval such that a lies in it 90% of the time. If you throw a die 100 times, it's going to be 3.5 minus 0.54 comma 3.5 plus 0.54, which is the interval, or which is equivalent to the interval 2.96 comma 4.04. So this is a, This is B, and that's the answer for part 1.